Extra click or two this time.
Hmm.
Do. So what's going on, John?
Oh, not much. Just coming back from a great evening last night of startup drinks and hearing pitches, and it's great. How about you?
Funnily enough, I was at the same event,
Yeah.
and you can tell probably our voices aren't at the same rigor today. So we're talking that maybe on our investor drink days that we might move this to Thursday mornings instead of Friday mornings, but we'll figure that out for the next one.
For sure. Yeah, no, but it was still a great event. Um, Lots good turnout actually.
Yeah, we had something like 65 to 70 people there.
Yeah.
It was a good event. Yeah, lots of good interaction. The feedback's always good. I love hosting those events. It gives me energy, even though I don't sleep the next night.
Yeah.
But it's the energy in the room is amazing, and it's always good to have startups and ideas and advisors and investors in there. It's just amazing the conversations that get sparked.
It's funny. No matter what, there's always at least 5 or 10 new pitches, people coming and talking. So it's in. I think there was more this time, but it's always great to see all that.
Absolutely. We got a lot to talk about today, and we are let me get this going. We are a little tired, so we might as well jump into it just because it might take us a little longer to get to our points for some reason or another. And damn it. Maybe. Okay. What? Great. It's working.
There we go.
I have this plug-in for StreamYard that helps that allows it to see Brave stuff because otherwise you're not supposed to see it.
Okay.
So anyway, welcome back to Futuretech Live. I'm here with my co-host as always, John Irwin, and we got a lot to talk about today. And I think the first one we're talking about is the quantum internet, the first unhackable shopping transactions carried out on the quantum internet. What's
Yeah.
going on here?
Really cool stuff. So a lot of new stuff coming out of China. So researchers in China have recently carried out it's more of a proof of concept demo of a secure online shopping transaction using a quantum network, which represents the first real world application of quantum communications and cryptography. So what happened was the team at Remnin University, I think, built a small scale network of 5 quantum computers connected by several kilometers of fiber. This setup mimics how a future quantum internet could operate by mimicking the quantum states of photons to transmit and process information. What they were able to do was run an encrypted exchange simulating an online purchase between a merchant and buyer. So, by using quantum keys exchanged through the network, they were able to verify each party's identity and ensure the payment details couldn't be intercepted or stolen in transit, something which is pretty much not possible today with classical internet technologies. Now, again, this is limited in scale. But it does prove the viability of quantum techniques for bank level secure online shopping, even with quantum networking capabilities. So, as more entangled quantum systems are connected globally over time, a full-fledged quantum internet could fundamentally transform secure online commerce and data transfers. The cool thing about this is it illustrates how quantum mechanics offers new avenues for distributing trust and privacy at a massive scale, which is virtually impossible with classical means right now. So it gives us a glimpse into real world applications that are emerging as quantum technologies advance towards mainstream use. It's really cool. Now, again, you come out with new technology that's unhackable, eventually someone's going to figure out a way to hack it. But who knows when it comes to quantum? So there's a lot of interesting information here.
Yeah, I unhackable is always something I question because it's unhackable. Why? Because it's on a private fiber network, or because it's unencrypted, or because of the thousand other things that make it secure, or just because it's the newest thing and we haven't
Yeah.
applied the quantum computer to break the encryption to um it's interesting. I like the concept, but you know, we are years away from the quantum internet. So is there a hybrid solution or something that we can start leveraging along the way to make us more secure between now and then?
I think so. Yeah, there's a few things. So QKD, which is quantum key distribution, it uses quantum entanglement to securely generate and distribute encryption keys between nodes. So while the actual data transmission and processing would occur classically over existing networks, we could have a level of quote unquote unhackable security, not possible otherwise. You could do some quantum optimization. So leveraging quantum processors to accelerate optimization tasks like finding lowest energy configurations, optimal routes, even machine learning clusters, once we get to a point where it's a viable use. And then there's things like quantum simulation, quantum machine learning. And there's a new concept. It's called quantum resilient encryption or quantum secure quantum resilient encryption, which is the way that the algorithm is built. It should be theoretically, because no one's really tested these from a quantum computer, but should be resilient to quantum decryption. So there are quite a few companies who are developing some QREs out there, which is really interesting. But there's tons of other hybrid kind of solutions that are out there that could potentially quantum assisted sensing, which is incorporating quantum sensors like atomic clocks or magnetometers or quantum illuminators into hybrid devices for enhanced precision beyond classical limits. So a lot of cool, interesting hybrid concepts, viable hybrid concepts.
So if you're watching online, you can leave a comment on any platform, Twitter, YouTube, LinkedIn, and we can see it and respond to it. Thanks for watching. So how much of an issue is this? Like, from what I hear and understand, most of our issues come from social engineering when it comes to credit card theft and, you know, the how much actual of this fraud or stuff, or is the transaction online being hacked versus any other number of things?
Right now, not much. It's more of social engineering or exploiting zero-day vulnerabilities. That's how most of these hackers are getting your information and hacking things. But the theory of quantum computing is that it's going to be able to crack any current encryption within seconds, just because of the way that it's able to handle data and able to the algorithm is able to work through the encryption algorithm. So it's right now currently, again, it's just a lot of social engineering. It's installing malware, getting people to open up attachments or open up emails, and then getting access to someone's computer who has access to the database of that company. Speaking of which, I think Atlassian just had a huge hack, one of the biggest hacks in history. But I don't know what the source of that hack was. But again, it's again back to you. It's social engineering and exploiting zero-day flaws essentially in order to get access to a lot of this data. It's scary though.
Yeah, I agree. That's scary. That's why I look at this and say, okay, this is great. Can we apply this instead or in addition to, you know, our VPN? You know, I go to a coffee shop almost every day and I'm logged in public Wi-Fi. VPNs are only so much secure because you got your endpoints that are hackable, and there's a bunch of other things that people talk about, vulnerabilities and whatnot. But can something like this make it more secure where it's not just a transaction that's secure, but all your traffic?
Yeah, absolutely. I definitely think so. Based on my understanding of quantum mechanics and quantum physics and things like that, I think so. So again, right now, yes, but 20, 30 years down the road, once this is actually implemented, who knows what people are going to come up with in order to break this or hack it, right? Just like back in the day when we had, what was it? Um, who was that encryption algorithm that was unhackable, and then I think it was like 10 years ago it was hacked. So there's everything again. I think everything is hackable. We'll have to see when it comes to quantum, though.
Are you thinking PGP?
PGP? No, PGP hasn't been hacked, has it?
No, I know. I don't
No.
know the algorithm that
it
was
the
hacked.
was it something RSA?
Oh, okay. The RSA token
Yeah.
okay.
There
They've
was
got a
something on
few.
that. Yeah. But there
They've
is a
got a
cool concept out there that they're using for actually completely random number generation. I think it's from Cloudflare. And I don't know if you've heard this. I know we're digressing a little bit, but they've got a wall of lava lamps. And those lava lamps have cameras pointed at them. And those cameras are used to generate completely random numbers. And those are definitely, absolutely 100% random numbers, because it's not a computer generating it. It's based off of taking an instance of a lava lamp. So using that, I think, is a huge advantage in overcoming some hacking. But again, the next logical step here is quantum.
Yeah, I agree that you say the next logical step is quantum. I'm still a quantum computer skeptic. I want to see some proof that it works consistently versus some of the stuff we've been talking about. We had a whole episode on quantum stuff a while back. So I was looking at, was RSA that was hacked by, and their algorithms were stolen and whatnot.
Yeah.
When are we going to see something like this? Like, we always want to see the next stage in performance of encryption and protection, but we always talk about stuff, way in the future. And quantum, as far as I'm concerned, is way in the future. Some people tell us it's going to be right around the corner. But you're talking about quantum laptops are 20, 30 years away when we were talking about it, but different quantum technologies are closer. Are we going to see a hybrid closer? We talked about the hybrid, but what is going to be the first implementation of these things? And are we going to see them on Shopify accounts, or is it only going to be major?
Who knows? Yeah, maybe Shopify is working on something. Great Canadian company that we have there, but it's. I think we're far off. We do have these proofs of concepts, and proofs of concepts are great, showing that there is viability there. But when it comes to quantum, any kind of quantum entanglement, the qubits are very, very noisy right now, and we need to be able to quiet those qubits, noisy qubits, and so we're very limited in what quantum technology can do right now. In order for us to get somewhere viable, I think quantum encryption is closer than a full quantum internet, if that makes sense. But I'm thinking, if we're talking quantum laptops are 20 years away, I would say quantum internet is not too far behind that, maybe 15 to 25 years, right in the middle.
Wouldn't you assume that the quantum internet would be before laptops?
You would think so. Yeah, you'd have the big ass
server rooms and infrastructure.
Yeah, server rooms, and then you'd have your old 486 desktop type quantum computers, and then maybe we get to laptops. So maybe we just jump right to laptops. Who knows?
Yeah, I'm the quantum skeptic. I think there's going to be something else, and quantum's going to be a long way out, and we're going to come up with something else to jump to the next computing level. But we'll see.
What did I just read? I think there was an article I just read about graphene being used in chips, but who knows I think that's just for miniaturizing it more, not for the power that we need that relates to quantum. But
absolutely. So we'll have to see what happens. I'm excited about this because I like the interesting technology. I'm not really sure about how important it is to have unhackable shopping transactions, or what a leap forward this is versus how much of the actual in-process transactions are hackable now.
Yeah.
and get hacked, because like we say, most of the stuff we see is malware that's taken over, or it's social engineered stuff, like shutting down the big companies. Now it's this in the ransomware stuff that everybody seems to be being hit with, and no one seems to be doing anything about to stop.
Yeah, no, it's crazy. But again, there's so many limitations and challenges, and I see your skepticism, and I can see why you would be skeptic. But you know me, I'm the optimist here. I'm the optimist prime here, and I do see it. But again, I haven't done a deep dive into actual, like, where we're actually at with a lot of this stuff, other than articles and doing some deep some follow up on that. But I'd be interested to see. Yeah, I did see one quantum computer, IBM's at CES, which was really cool to see. But apparently, the size of it is mostly just because it needs a lot of cooling.
Makes sense.
Yeah, just like the first computer, right?
Yeah, so it'll be interesting to see where this technology goes, and we'll keep an eye on it and keep you informed here.
Yeah.
And as we start to switch gears, we're heading over to our next topic. John, what's going on with these nuclear batteries that last 50 years without being charged?
Another Chinese article, or based from a Chinese startup called BetaVolt, which they've unveiled a new type of battery called a atomic energy battery. It supposedly generates power from radioactive isotopes for over 50 years without needing charging or maintenance. So apparently, the battery utilizes 63 nuclear isotopes sealed in a coin-sized module that converts the energy released from their decay into electricity via a process that was first explored in the Soviet Union and the US. And so apparently, and I say apparently because this one I'm really skeptical of. BetaVolt claims that its battery produces 100 microwatts, which isn't that much, of power at 3 volts initially, but they're aiming to produce 1 watt by 2025, and multiple batteries combined together in series, just like we learned back in school, could be used together for a higher output. Again, there's tons of potential applications. If phones would be great, drones that could fly indefinitely, medical devices, sensors, space technology. So the reason why space technology is because apparently it's stable in harsh environments. So they say that they're safe as the radioactive material is sealed and does not emit radiation, but there is a lot of shielding around it. And if they do scale it up, they're going to have to, as they scale it up, they're going to need more shielding. So after the decay, the isotope becomes a stable copper, apparently. So what they're saying is likely isotopes include, and you'll like this, tritium, hydrogen-3, which is commonly used in neutron generators or radioactive luminous paint due to its low energy and safe emissions. But again, proper containment is key. So again, this is one where I'm skeptical of it. It's based on my understanding of, and again, I'm not a nuclear physicist or engineer or anything like that, but there is potential here, maybe.
There is potential here, maybe. I like your confidence. It's interesting. We were talking about, we just did an episode on 6 gigahertz, terahertz waves and how that could affect us. And how we're moving them closer and up in the amperage and all that stuff. What is going on with radioactivity coming out of this? It's a pretty small looking battery we're seeing. We see a couple different sizes that were coming up in the video we were looking at. Is it, enough to power our cell phones now? And like, how many would we need? And what's the radiation of these things? Like, you mentioned it, and do we really want to be walking around with these radioactive devices in our pockets? But at the same time, I'm asking you about backyard nukes, right? So
exactly. Like, I think that this would be a great technology to replace like those Tesla battery balls, right? Because then it's not right up against your skin in your pocket. There's a lot, you're a lot more distant from it. There's different things like that, or even in cars. But I'm not sure if it, obviously it definitely needs to scale in order to get to the power needed for cars. But to be honest, I don't even know what the draw from a cell phone is. I have to look that up. But again, the thing is okay, sure. It could last for 50 years, and my biggest concern is what happens like if you go, obviously, because the operating temperature range, essentially they claim from minus 60 Celsius to 120 Celsius, so it could survive a plane trip if you go up in, because they're looking to use this in space too. But what happens if we get into like the battery gate with Samsung? This time, it's not just a regular battery that's not radioactive. We have a radioactive battery. So, power consumption for a phone is when it's on standby is about 0.5 to 1 watts. When the screen's on, it's about 1 to 2 watts, or 2 to 3 watts when you have max brightness and you're doing tasks like video games and stuff like that. Same with browsing and scrolling. So you're talking max maybe 5 watts of use at a time. So. And they're talking about their goal by 2025 is to get it to 1 watt.
Yeah, and that's a 15 by 15 by 5 cubic millimeters. As if you can take a look here, it's pretty small.
Yeah, you put like 10 of those, you've got the same size of a regular battery, cell phone battery.
I don't know how big the batteries are in the cell phones anymore, because they squish them and make them and they pour them and they do all this different stuff and fill in all the gaps with batteries. So it's hard. But you would figure they'd be, obviously you wouldn't want to do that with this technology. It'd need to be shielded better. But yeah, it doesn't sound like it's too far away, especially, if one is to generate 1 watt, you get 3 of them in there. From a generating point of view, combination of this and regular batteries, you have these just charging your batteries on the go. So your regular lithium ion or some of the sulfur ones that we were looking at or talking about the other day, I can't remember what were those solid selenium, solid state selenium. Yeah, sorry, I know what sulfur. Geez. I'm tired from I said sulfur. I'm tired from last night's drinking event. That you combine these things and it looks like you would have something, right? Because even if at full power you got a phone that generates 3 watts, at a time, but you're consuming 5, and you have the combination of a lithium ion or solid state selenium in this, it's just charging it when you're at low usage and that kind of stuff. So I could see a combination of these things working if people are willing to deal with the radiation of this. And are there any costs? Go ahead. Sorry.
Well, and that's if cell phones continue on the same path. Like we just did something on the Rabbit R1, and we talked about the humane pin. If they get smaller like that, who knows? Like this one small little cell could power those things, right? Because they have a small screen or no screen and very little interface. But
yeah, there's a lot of stuff that we could do here. We are talking about the glasses, AR, VR. We're talking about a lot of these things that the problem, even the autofocusing glasses, the problem, a lot of these things is battery life. And, as battery life, something like this actually looks very promising because it solves a bunch of issues. Like, we're not just throwing batteries out all the time. So environmentally and recyclable, it's better. We're not using as much, ideally, of rare earth minerals because there's a lot of, but again, we don't know what mass consumption of this looks like or what we think we can get the costs down to.
But this, remember we were talking about wireless energy for recharging, that would eliminate the need for that. So one less signal that we would need, but we're trading it off with some radioactive isotopes.
Yeah, I think we're gonna end up with both.
Yeah, I think so.
So,
Yeah.
and again, I think some of these things will be, especially when they get started. If we're looking at 1 watt in 2025, we're that's 11 months away potentially. It's not
Yeah.
far. So people could easily be thinking about, okay, how do I put this in my products? If I was a cell phone manufacturer, I wouldn't want to be the first with this because, yeah, you don't want to be that person unless there's done a lot of safety
Yeah.
testing,
For sure.
that because you're putting the phone right beside your head, right?
Well,
There's
if we take Apple's adoption into consideration, Apple probably wouldn't put this into their phones for the next 50 years. They're so slow to adopt new technology, right? So
well, that is absolutely funny. Apple is, used to be one of the people forcing the market ahead.
yeah,
And now they're dragging their butt on everything. Like, they don't have touch screens in their laptops. They
no,
don't have foldable screens. There's a lot of things they don't have, and they're really starting to come behind. Now, don't get me wrong, like, their touch screens on their iPads and stuff are great.
yeah.
But I think we all figured they'd be a little bit closer from a touch screen interactive by now.
Yeah. Well, even the software, like they're just implementing features now that Android has had for over 10 years for some of them. Like it's crazy.
Yeah, I used to say, these phone companies leapfrog each other, like, every 6
Yeah.
months, one will come up, but now I think Apple's just way behind.
Yeah. Apple's way behind. And the thing is though, is I get it. They are releasing phones that just work. Like that's all it is. Like it works and battery life is good. Um, but if you want additional customization features and things like that, and they finally, like with iOS, I think 16 or 15, they introduced some widgets which Android had since I think one of the first two iterations of Android. But it's just it's nuts.
Yeah, you say, it just works. That's kinda debatable, but it's way behind and it's overpriced now. So people really need to start taking a look. Like, I love your foldable flip phone, with
Yeah, I
the
love it. The
touch
battery life
screen and
is
stuff.
crap, but yeah,
But that, those, you got the first one of that model, right? And it's amazing looking. If people haven't seen it, the foldable color touchscreen is amazing.
yeah,
And he got that thing on the outside, the screen on the outside to tell you the stuff going on. But yeah, that's way better technology than what this has been for how long, right?
yeah,
And there are so many technologies we should be jumping forward in the ecosystem, but they are the laggards. They're falling behind. They closed a couple stores recently, and that's usually a sign for me that
yeah.
it's not what I wouldn't say the beginning of the end. Apple's not going anywhere,
No.
but their market cap's going to drop a bit because they really need a shake up to figure out what's going on. And I don't think their VR glasses are going to be the next big thing.
No. But I think they did just overtake Samsung as the world's top smartphone seller, which great for them. Just people are
Absolutely.
thing is Apple's done a great job of once you're part of the ecosystem, that's it. Like you're in and so
They
um
lock you in, yeah.
yeah, they lock you in, which is why they probably don't innovate so much, is because they have you locked in and you're kind of forced to keep upgrading to Apple and getting the new devices and things like that, especially when they start slowing down your phone because your phone is getting old, like craziness.
Yeah, obviously they got sued for that.
Yeah.
But yeah, they need to definitely step up their game. Not only did they overtake Samsung as the number one phone seller, but Microsoft overtake them as the highest market cap. So they're losing market cap at the same
Um,
time
uh,
as, and going into the streaming world, they got to be losing money hand over fist, profitability on different levels. Their profit margins are lower than ever now. So it's interesting to see where their next big thing comes from, because the iPhone and the App Store and iTunes is dwindling now, not increasing, I think.
Yeah. Don't get me wrong. There's one product of theirs that I absolutely love, even though it doesn't have a touchscreen. It's the MacBook Pro. I've I even have one that's 12 years old that I can still use on a daily basis with no problems at all. So their Mac OS and their design is good, but not a fan of anything else really. It's just mundane.
And again, I'm not hacking Apple. I'm in the Apple ecosystem. I'm on a M1 Mac Mini now talking to you, and I've got a MacBook Air as my daily driver.
Yeah.
And I've been using Macs for years. I used to be a Windows only person, and I, thought Mac people were losers or whatever. And then whatever it is in that Windows Mac environment. And then I tried it and it was amazing. And I tried it for different reasons because I was doing development at the time and didn't look back. So it's just one of those things you either like it or you don't.
Yeah.
But yeah, you get locked in the ecosystem because I have the apps that map on my iPad, on my phone, and on my Mac. And if you go switch to Windows or something else, you're like, okay, well, I need apps that integrate with all these things. Anyway, back to nuclear batteries because we're way off.
Way off topic, but hey, that's great.
Yeah, because that's the other thing. We're talking about laptops. I want to see nuclear battery in my laptops. I want to not have to plug in every, be worried about, especially with my MacBook Air. It's great, but I've got an old one. I'm going to upgrade this year. But I start doing any sort of audio editing or any sort of thing that you choose up the CPU and the battery drops so fast. So you got to be near a charger if you're doing heavy work with it. Something like this would really change things. So if the future plan is to get 1 watt in 2012, when are we going to see commercial viability?
Yeah. I would say there's a whole bunch of hurdles before they get to commercial viability. There's certifications and testing that are going to be required. A lot of testing, a lot of different certifications. There's so much so many hoops that they're going to have to jump through. Even if they get a viable commercial product that is like working, honestly, I would say if they can demonstrate it and pass everything, I'd say 5-10 years.
Yeah, because that's not far away.
No, because like if they can produce a cell that size that produces 1 watt, you put 5 of those together, that you get your 5 watts max, which is what a cell phone drains max. That's probably about the size of a cell phone battery currently. So yeah, I don't see it, but again, as long as they can overcome those certifications and testing hurdles that are going to be quite extensive, much more extensive than any other battery technology, right?
Yeah, and I see, like, I think you mentioned it when we were talking before. I see this being put into drones and other things that are a little bit farther away from humans at first.
Yeah.
Although you might handle it or whatever, the most, it's flying or it's away. It's not physically on you or your laptop sitting, near your junk all day long, seeping radiation. These things aren't good, but that's why those things. But yeah, 2030, I'm all in. This looks like a great leap forward to be moving, and we'd love to start seeing these things go big. When I say go big, I'm talking about let's start replacing solar cells and large batteries in homes to start dealing with the power grid problem when we have homes that can regenerate power. Maybe it can't handle its max load, but you got batteries, you got this, you got that, and you're always recharging. You've got a different kind of grid and world at that point.
For sure. Yeah, our power grid is so old and it's so fragile. We need some sort of solution soon.
Yeah, and everybody loves those EVs, and they take so much power, more than all your other home stuff combined, which is great. But what does that do to the grid? And we've talked about that before. And we need some solutions for these things.
We do. Yeah, this definitely cannot go into EVs because what happens if you crash and that seal breaks? So unless they get something there, but yeah.
Yeah, that's why I'm thinking in the home where you charge your EVs, right? So if it's generating power and you can do a slow charge, or it's charging batteries in the home, always keeping it charged, so you're not drawing from the grid as much, you've got a different kind of solution.
Absolutely. Yeah.
But yeah, now you're living with a radioactive Now we're getting close to backyard nukes.
Exactly. Yeah, it's we're getting to there. This was a
You're gonna
concept back in the 50s, 40s.
absolutely. You're gonna say something else there?
No.
All right. Just so we're gonna reset here and jump to our next topic because that was very interesting. Let me just change this. So the next one we're talking about is warp drive.
Yes.
So read this article. Warp drive is just around the corner. What does that mean?
Yeah, just around the corner. Just around the corner, I'd say like 50 years away around the corner. But that's just me. But here's the thing. So as you know, the concept warp drive was first introduced in Star Trek, allowing for travel that's faster than light. It was then again visited in a show called Eureka, where they were testing an FTL drive with a catcher and all that sort of stuff. So there are some great TV shows that have captured the concept. So the thing is, in 1994, theoretical physicist, and I hope I pronounce his name right, Miguel Alcubierre, he proposed a theoretical concept, and it's called the Alcubierre drive, where the spacecraft could travel within a warp bubble that contracts space in front and expands it behind, moving the ship faster than light without violating relativity. Interesting. So, while theoretically sound, up until this, whatever this article was published or the work was done, it was thought to require exotic matter that didn't exist. However, a team at NASA's EagleWorks lab successfully produced microscopic warp bubbles in plasma using electromagnetic fields, demonstrating the geometry proposed by Alcubierre. So the exact mechanism that they used to generate the warp bubbles involved a specialized laser to excite a cloud of hydrogen plasma into kind of a donut-shaped field configuration. Again, this is crucial. It's a crucial POC, proof of concept, that warp fields may be physically produced and generated. But there's tons of challenges remain to scale this. But it does give credibility to the concept. Now, on top of that, continued research led by scientist Harold White aims to optimize and reduce the immense energy requirements that are proposed from this POC in early warp drive models through innovative geometry and design concepts. So again, we're super, super early to this, but we've overcome a key hurdle where we thought it was theoretically impossible, and it is theoretically possible now. So that is a huge leap, I would say.
Absolutely, it's a huge leap, but being theoretically possible and then doing it are two different things. Like, you know, they say time travel is theoretically possible, but I've read an article saying it isn't now. But you know, everyone's so another theory will come along and say something different. But let's assume it's theoretically possible now.
Yeah.
What are some of the challenges of trying to get a warp field to a useful size?
Yeah, well, the first thing is going to be containment, right? You have plasma warp bubbles at EagleWorks. They were only microscopic, which is far below the scales needed for vehicles. So containing and shaping those exotic high energy fields poses daunting engineering obstacles. And the other thing that I was thinking of too, if we're talking about these warp bubbles, is that the same thing as I'm just going to digress here for a second. Is that the same thing as a force field? Maybe, I don't know. But the other challenges are stability. So what they saw was small disturbances grew bubbles unevenly. So larger fields are going to require exquisitely detailed control to maintain distortion geometry far from equilibrium, or effects could dissipate way too rapidly. Energy input. So the bubbles required intense laser power, and they're likely impractical at larger sizes at this point. So alternative mechanisms with constant distributed energy profiles must be developed. Material stresses. So space-time curvature induces enormous pressures between normal and warped regions. So there's so many theoretical stresses over prolonged use. And there's tons of other ones: field uniformity, guidance and control, again, safety testing. What happens if you're in warp and the bubble collapses, right? So there's so many different there's a lot of validation, extensive validation, that's going to be required before we can even start to think about this at scale. I think you're on mute there, Craig.
I was on mute, sorry, and it kept going on off here. To answer your question, is a warp drive a warp bubble a force field? No. If anything, it's a gravity field, as we were just talking about, because it's only if the field manipulates in specific ways in order to move a ship faster than light, rather than protecting you in one spot.
Okay, interesting. So yeah, and just to get back to it, like the theoretical ability to actually manipulate space-time, it's going to require breakthroughs in exotic phenomena like negative energy, matter, which we have no known means to produce it yet. So and the other thing too is the one thing, and if you think back to your Star Trek days too, is we're going to need compact fusion or antimatter drives, potentially, to supply the kind of energies that's theorized in order for these to produce these at scale.
Yeah, because Joseph Agnew's testing this theory, right? And this requires a massive amounts of energy. But I don't know what massive amounts of energy is. You say fusion drive. So if we're trying to do it here, do we need multiple nuclear reactors to create, something? Or is it
at scale? Potentially, that might not even give us what we need. Who knows? I didn't explore what the power draw was. I don't know if it talked about it in the article. I don't think it did, but
and it was hard to say because we're talking about microscopic fields, right?
Yeah, but you can always scale that up with an equation, right? And that's another theoretical equation, or a theoretical number, because it might not scale it might not scale linearly, or it might scale exponentially. Who knows? I'm not an expert in warp drives, so I wouldn't know.
So we talk about this and say, all right, so it's theoretically possible. They're working on figuring out how to do this, create warp drives, warp bubbles. We need a massive amount of energy. So we're talking about compact fusion, or if we're in the theoretical world, antimatter drives. Where are we with any of that technology? As your keyboard goes crazy.
Yeah, no, I'm looking it up where we are with antimatter, because I have no clue.
I figured.
That's a good question. So what they're saying is it's still experimental. So CERN is good. I'm glad CERN came up, because that's what I was hoping for. They're capable of producing antimatter particles like antiprotons and positrons through high energy particle collisions, although quantities remain tiny. And I think there's a huge thing with containment of antimatter, or that just might be from the movies. But so containment using magnetic and electrical fields. Scientists, they've been able to isolate and hold cohorts of antimatter atoms like antihydrogen for over 1,000 seconds. Previously, they would annihilate in microseconds, so they're getting closer. Experiments continue probing questions like whether antimatter obeys all physical laws as the same as normal. So far, the tests have shown no anomalies. But the energy potential, this is why they're saying the energy, 1 gram of matter of antimatter annihilation yields 1.8 times 10 to the 13 joules of energy, which is huge. It's about, so 1 gram is about the output of a small nuclear bomb. So that's why antimatter would definitely be useful for these, for the warp drive.
Yeah, because there's a massive amount of energy. I know they're working on some sort of warp field interferometer that aims to detect and generate warp bubbles at NASA. So, you know that people are taking it seriously when, CERN and NASA are working on these things.
Yeah, absolutely. Yeah. We just, I think, again, there was, I can't remember what movie it was where they had antimatter in a containment kind of tube,
Yeah.
and that if that containment broke, that it would destroy the world or something like that. I can't remember what it was, or create a black
And
hole. I don't
who
think.
makes these things that, like, let's just put the world's most destructive thing in this vial that someone could just drop?
Yeah, exactly. Who knows? That just might be a movie picture concept that's not real, but we are getting more real with a lot of these movies nowadays, especially with Interstellar, where I sorry digress, but what they came up with as far as how to represent black holes is now being used in science, which is pretty cool.
It's always interesting when these new theories change. I wasn't necessarily a fan of Interstellar, so the fifth dimensional bookshelf did it in for me, but that's a whole other discussion.
Fair enough.
But it doesn't mean that some of the sciences makes you think about it. And let's face it, science fiction leads science in a lot of ways. The stuff they invented in Star Trek is now reality. We now have cell phones. We can call Scotty and stuff, and we can do a lot of the things. We can talk to computers. We can, things we couldn't do back when they came up with this in the 60s.
Yeah. The one I'm worried about is the beaming technology, because from everything I've read, is in order to do that, they would have to completely destroy you and duplicate you at the destination. So it's a copy of you every time that you are beamed.
Yeah. So the question becomes, though, we say have to destroy you. Do they actually have to destroy you, or um do you physically atoms break down in the process of transfer, or just because we're cloning you, we have to put a bullet in your brain on this side so the two of you don't exist?
No, I think it physically, well, based on just the concept, theoretical stuff that I've read, is it'll break down your matter or your atoms and then redraw you. I don't know, just I don't even know the word for
So
it.
that's got to be excruciating. It rips you apart at the atomic level and destroys your
Exactly.
very being, then puts you
Yeah,
back together. It
exactly.
doesn't sound like something I want to go through.
No,
But
thank
at the
you.
same time, we did the talk on teleportation, and based on this whole same technology, there's no reason why they couldn't teleport me from my fat body into a healthy muscular body. So
Well,
I might go through some pain for that.
yeah. Well, we are getting close. I think we talked about this, is consciousness, digital consciousness or artificial consciousness, right? And uploading your consciousness. How many times can I say the word consciousness? But it's where I think Elon Musk was talking about that, is he wants to do that.
So, you know, are we talking about time travel when we're talking about warp drive?
So potentially, because as we as we get closer to the speed of light, it's essentially like traveling back in time because of the relativity of it. But I don't know if the warp bubble is going to help solve that. But based on um, based on the math and the physics, the closer you get, the slower time goes by. I think as it
The
is.
time dilation?
Yeah, time dilation. Yeah.
I've watched some sci-fi in my time.
Yeah.
Yeah, that's why I wonder, because it says, we're talking about this, and this whole warp drive suggests that warping space-time to achieve speeds exceeding light, which is what you need if you want to travel great distances.
Mhm.
Because it doesn't necessarily mean, well, it does actually. If I travel to Mars at the speed of light, or faster than the speed of light in warp drive, that I'm getting there, in a millisecond, where light takes maybe minutes to get there. And I just wove 10 minutes back in time as an example.
Yeah, potentially. Um, And the other thing to think about too, since we're talking about time dilation, is the difference in time dilation between Mars and Earth. Right? So Mars has a weaker gravity than Earth due to its smaller mass. So gravity at the equator is about 38% of Earth. So weaker gravity means that time passes more slowly, according to a time relativistic, I think it is, time dilation caused by differences in gravity potential. So on Mars, time passes about 0.004% slower than an equivalent period on Earth. So for every 1 year that goes by on Earth, a Mars year would be about 0.004% longer. So for every 100 years that pass, I know it's not a huge thing, but for every 100 years that pass, about 100.004 years Mars years will elapse.
And so if you went the other way in a heavy environment, it would be longer?
Yes, shorter.
Shorter. Okay.
Yeah.
So if I was in a heavy environment and I was 20 Earth years old, I might only be 16. Let's just throw something out there based on.
Yeah, and that just goes to show how accurate Interstellar was, because they were showing that. Remember, one of the planets that they were on, because they were so close to the black hole, time was passing by much faster.
Every sci-fi that goes on the edge of black holes shows this. So don't say they were revolutionary.
Try to get you on board with Interstellar there. Come on.
I get that you like the movie. You don't have to keep pushing it on me. But no, the concepts are very interesting around like what we're doing here, because we need, if we actually want to travel to other worlds and populate planets, we need a warp drive that knows close to speed of light won't do it.
Yeah.
Because it's just going to take generations to get anywhere.
Yeah.
So we need something like this. The question now becomes, are we going to be warping across the planet? Like, okay, we got a little warp bubble. I'm in Japan, but I got a meeting in New York, and I'll just walk through this little bubble and I'm over there.
Hey, that's a great idea. Yeah. Who knows? But isn't that once we get warp technology, that's when we'll be visited by the Federation? I think that's what it is. You have to get to warp technology before.
Well, it depends what you read. If you like to read So Long and Thanks for All the Fish, I can't remember his name, the guy who did Hitchhiker's Guide to the Galaxy.
Oh, yeah. What's his name? Anyways.
Yeah, we're gonna all get blown up the Earth's gonna get blown up to make room for the interstellar highway.
Yeah. Oh, yeah, that's right. That's what it was. I'm gonna read that. Yeah.
So yeah, but we're gonna, if there's aliens out there, eventually we'll get their attention as we start warping this, creating warp bubbles and destroying space time everywhere.
Yeah, for sure. Yeah.
All right, this has been interesting. I like where this is going, and I want to delve heavily into where warp drives and space time in a future episode. But we got a lot going on, and we're getting close to the hour here. On Wednesday, we're going to be talking about this Scale AI program. What's going on with it, John?
Yeah, so Scale AI is an awesome digital supercluster, government funding, non-dilutive. If you've got a project that is AI, but as it's trying to solve a supply chain problem, join up. Let's talk Scale AI. Let's talk projects, and we'll talk about how to access that funding.
Yeah, and the reason why John and I are a little tired today is last night we had our monthly startup investor drinks. The next one is February 29th, and it'll be posted by tomorrow morning. I'm a little tired today. I'll get it up this afternoon. But if you go to startupdrinksto.com, you can check out and grab a ticket there. Join John and I. Last night we had, I don't know, almost 70 people, 65, 70 people out. And that's usually an average turnout. Next month, I expect about 70. March will be big. We'll probably be close to 100 just because of the situation. Come out and join us. It's a great event. Meet some fellow entrepreneurs, talk tech, talk entrepreneurship. It's amazing. The other event I want to mention coming up is if you go to mentoringmagic.ca, we have a co-founder matchup event with Futurepreneur and Consulta, where it's going to be an interactive event. If you're in Toronto area and you're looking for a co-founder, come on out. Go to mentoringmagic.ca and sign up. Get your ticket. there's a form there asking you to what skills you offer and what skills you're looking for, because are you a developer looking for a business development person? Are you a salesperson looking for someone to help you develop what it is you're looking for? And we'll start doing some matching. There's going to be some games and some stuff, and we're going to have Siavash from Shakarian Law in talking about co-founder prenups, just so you understand what kind of stuff you're getting into as well. It'll be a great night out, so join us there. All our other stuff is at torontostarts.com. If you want to work with me, go to torontostarts.com, click on the startup coach page, book a discovery call, and we can chat. If you want to reach out to John Irwin on LinkedIn, reach out if you want to talk about funding. What else?
Funding, if you want to geek out, if you want to talk government funding, non-dilutive, that's my area of expertise. If you need some coaching, other than specifically as it relates to grant strategy and things like that, feel free to reach out. And I actually do have an event that I'm attending to promote too. So on February 20th, I'm going to be taking part in a roundtable with two other phenomenal people talking about HR, branding, and funding. So
the Creator Club event, King Street Media.
Yes.
Yeah, they're great.
Yeah. So Eric,
where do they go?
Eric's putting that on, and he's a phenomenal guy. What's that?
Where do they go to find information about that?
Message me on LinkedIn. I don't have the link. I'll send it to you for next time, because it's we'll be able to talk about it.
Yeah, you sent me that stuff.
I was prepared to talk about an event for once, but not the link. But we'll get it to you.
Absolutely, we'll get it down. If I'm happy to throw this stuff on the screen so people can grab it. Anyway, that's it for this episode of Futuretech Live. Don't forget to check out the podcast at torontostarts.com/futuretech. Where we break these down into episodes, and you'll never miss one topic we talk about. And that's it for this episode, and we'll see you next time.
Awesome. Thanks, guys.